Hello friends, welcome to SSP Math. Today we are going to start new topic, that is inner product spaces. In last video we already learned vector spaces. Now how to define inner product spaces. So definition is, let V be a real vector space. Suppose to each pair of vectors UV belongs to V, each pair of vectors UV belongs to V, there is assigned a real number denoted by inner product of UV, called as inner product on V, if it satisfies the following properties, means if satisfies these three properties. So first property is linearity property. Now what is linearity property? Inner product of AU1 plus BU2 comma V is equal to A into inner product of U1V plus B into inner product of U2V, this way, U1V, U2V. Okay, means what is linearity property here? Inner product of AU1 plus BU2 comma V can be written as A into inner product of U1V plus B into inner product of U2V. Then second property is symmetry. Symmetry means inner product of UV is equal to inner product of VU. And third one is positive definite property, that is inner product of U comma U is greater than or equal to 0 if and only if U equal to 0. If these three properties are satisfied, then we can say that inner product of UV is an inner product on vector space V. Then next one is norm or length of a vector. So how we find norm or length of vector? So the non-negative real number norm U is called norm or length of a vector and is defined by norm U is equal to under root of inner product of U comma U. Norm U is equal to under root of U comma U. Okay, inner product of U comma U. And how we write inner product of U comma U? If we take this U is equal to this vector, so inner product of U comma U can be written as under root of A1 square plus A2 square plus so on plus AN square is key value. Okay, then next one is Euclidean space. Euclidean space means consider the vector space Rn. The dot product is defined by U dot V. U dot V is equal to A1 B1 plus A2 B2 plus so on plus AN BN, where U is equal to A1 A2 up to so on AN and V is equal to this B1 B2 up to so on BN, be the inner product of U and V in Rn, and norm of vector U is defined as norm U is equal to, जो मैंने यहाँ पर एक्सप्लेन किया, norm U is equal to under root of U dot U, and under root of U dot U means this is the inner product of UU. In Euclidean space, inner product of U comma U can be written as U dot, or inner product of this U comma V can be written as U dot V. Okay, so norm U, how we write? Norm U is equal to under root of U dot U. Under root of U dot U means under root of A1 square plus A2 square plus so on plus AN square, if U is equal to this A1 A2 up to so on AN. Okay, now the vector space Rn with above inner product, means this U dot V. The vector space Rn with above inner product means this U dot V, and norm means this norm is called Euclidean N space. Okay, so what is Euclidean N space? In Euclidean N space, inner product of UV can be written as U dot V. Okay, and norm of U, how we define? Using this. Now one remark is there in Euclidean space, same remark is, that is inner product of UV is denoted by U dot V, and second remark is, if vectors represented by column vectors, then inner product of UV is equal to U transpose into V. Inner product of UV is equal to U transpose into V. Means for example, suppose we have to given that this vector u and this vector is v. Okay, and we have to find inner product of these two vectors. So how we write here, inner product of uv is equal to, we have to write u transpose into v. Okay, then next one is distance between two vectors u and v. So how we find distance between two vectors? Distance between two vectors u and v is denoted by d of uv and read as distance between u and v, and is defined as distance of between u and v, that is d of uv is equal to norm of u minus v. And how we write norm of u minus v? That is under root of inner product of u minus v comma u minus v. This is the norm of u minus v. Okay, means for distance between, suppose we have to given that first vector is u, second vector is v, and we have to find distance between u and v. So first find u minus v, then take its norm. Okay, how we find norm? Using this. Then after distance between two vectors, we have to find angle between two vectors. So suppose the angle between two vectors, means u and v are the two vectors belongs to v which are unique. So this angle is, say, theta. Angle between u and v is theta, can be calculated using formula cos theta is equal to inner product of uv upon norm u into norm v, where 0 is less than equal to theta is less than equal to pi. Okay, so these are some basic concepts. Now we will take some problems. So first problem is here, examine which of the following functions defines an inner product on R2 for u equal to x1 x2, v equal to y1 y2. Okay, so here u given a x1 x2, v equal to y1 y2, and inner product of uv is defined in problem, that is inner product of uv, if we take u equal to this, v equal to this, then can be written as x1 y2 plus x2 y1. Okay, now we have to check that three properties here. First one is linearity property, second one is symmetry, and third one is positive definite property. If that three properties are satisfied, then we can say that inner product of uv is an inner product space. Okay, so first we have to assume here z is equal to w is equal to z1 z2, means we have to take u is equal to this, v equal to this, and w equal to this. Okay, so what is linearity property? In linearity property में हमने क्या देखा था, a u1 plus bv. Okay, so same here we have to find first au plus bw. Au plus bw can be written as a into x1 x2 plus b into z1 z2. These are the two matrices. If we multiply a and b inside, and if we take addition, then we will get this, that is matrix ax1 plus bz1, ax2 plus bz2. Now we have to check linearity property. Linearity property is inner product of au plus bv comma v, au plus bw comma v. We have to write is equal to a into inner product of uv plus b into inner product of wv, means this. Okay, so how we write this now? If we consider here inner product of au plus bw comma v is equal to, now what is the value of au plus bw? That is matrix ax1 plus bz1, ax2 plus bz2 put here, comma v is y1 y2. Okay, now what is inner product of uv? कैसे define किया है? x1 y2 means suppose u is this and v is this, तो inner product कैसे define किया है? x1 y2 का product plus x2 y1 का product. Okay, so same here, ये जो ax1 plus bz1 है दिस, इसका प्रोडक्ट किसके साथ आएगा? y2 के साथ, मीन्स दैट इज दिस स्टेप ax1 plus bz1 into y2 and plus ax2 plus bz2 into y1. Okay, now multiply this y2 and y1 inside. So if we multiply, then we will get this step, that is ax1 y2 plus bz1 y2 plus ax2 y1 plus bz2 y1. Okay, now write down all terms of a in one side and b in another side, means write down all terms of a in one bracket, means this, that is ax1 y2 plus ax2 y1 right here, and plus bz1 y2 plus bz2 y1 right here. Now from first two terms take a common, means this we get this step and from last two terms take b common, then we will get a into x1 y2 plus x2 y1 plus b into z1 y2 plus z2 y1. Now what is this x1? This one x1 y2 plus x2 y1, x1 y2 plus x2 y1 is inner product of uv, so we can write a into inner product of uv plus same z1 y2 plus z2 y1 is inner product of wv plus b into inner product of wv. Okay, so linearity property is satisfied here. Now we have to check symmetry. Symmetry means inner product of uv is equal to, सिमेट्रिक प्रॉपर्टी क्या है, इनर प्रोडक्ट ऑफ यू वी इज इक्वल टू इनर प्रोडक्ट ऑफ वी यू, ये आना चाहिए. ओके, सो इफ यू कंसिडर हियर फर्स्ट इनर प्रोडक्ट ऑफ यू वी, inner product of uv is defined as x1 y2 plus x2 y1 and this is commutative. okay, multiplication is commutative, we can write is equal to, इसको हम ऐसे लिख सकते हैं y1 x2 राइट फर्स्ट हियर and plus y2 x1 right here because addition is commutative. And what is this? This is the inner product of vu. So symmetry property is also hold here. Okay, now third property is positive definite property. So inner product of u comma u is equal to x1. Inner product of u comma u, how we write inner product of u means that is x1 x2 comma x1 x2. okay, and how we write this inner product is equal to, ये दोनों का प्रोडक्ट आएगा x1 x2 plus x2 x1 means we get this step x1 x2 plus x2 x1 is equal to 2 times x1 x2. now check here 2 times x1 x2 है, so if x1 is positive and x2 is negative means यदि ये x1 positive है x2 negative तो ये टर्म क्या आएगी, ये नेगेटिव आएगी. ओके, सिमिलरली इफ यू टेक सपोज x1 नेगेटिव x2 पॉजिटिव मीन्स x1 नेगेटिव x2 पॉजिटिव लिया तो भी ये टर्म क्या आएगी, नेगेटिव आएगी. मीन्स वी गेट इनर प्रोडक्ट ऑफ u कॉमा u इज लेस देन 0. सो पॉजिटिव डेफिनेट प्रॉपर्टी सेटिस्फाई नहीं हो रहे हैं, देयरफॉर इनर प्रोडक्ट ऑफ uv इज नॉट एन inner product space. okay, then next problem is find distance between u and v if u is equal to 5 5 8 8 and v is equal to 1 2 3 4 on r4. so this is very simple problem how we find distance between u and v. okay, so for distance between u and v, first we know that distance between u and v is equal to norm of u minus v. so we have to find first u minus v here. so u minus v is equal to 5 5 8 8 minus 1 2 3 4. so how we take subtraction of these two vectors here, same as matrices, that is 5 minus 1 is 4, then 5 minus 2 is 3, then 8 minus 3 is 5 and 8 minus 4 is 4. so we get 4 3 5 4. so this is the difference u minus v. now we have to find its norm. we know that norm of u minus v is equal to under root of inner product of u minus v comma u minus v. okay, so if we take it square, so norm of u minus v का square क्या आएगा, जो अंडर रूट ऑफ a1 स्क्वायर प्लस a2 स्क्वायर प्लस था तो उसका रूट निकल जाएगा, यहाँ पर आएगा 4 स्क्वायर प्लस 3 स्क्वायर प्लस 5 स्क्वायर प्लस 4 स्क्वायर. okay, so 4 square is 16 plus 3 square is 9 plus 5 square is 25 and plus 4 square is 16. if you take addition of this all elements, that addition is 66 and therefore norm of u minus v is equal to under root of 66. why we write here under root, because norm of u minus v is defined as under root of inner product of u minus v comma u minus v. okay, then second problem is same here, find distance between u and v if u equal to 5 4 v equal to 2 minus 6 on r2. so first find u minus v, same as last problem, that is 5 4 minus 2 comma minus 6 is equal to 3 10 means this 5 minus 2 is 3 and 4 minus minus plus 6 is 10. okay, so norm of u minus v whole square, how we write, that is 3 square plus 10 square, 3 square is 9 and 10 square is 100 is equal to 109 and therefore distance between u and v is equal to norm of u minus v and norm of u minus v is equal to under root of 109. so distance is root of 109. okay, then next problem is find angle between u and v where u equal to 5 1 and v equal to minus 2 3 in r2. We know how we find angle between two vectors using this formula, that is cos theta is equal to inner product of uv upon norm u into norm v. So for this what we want, first we want inner product of uv, then find norm u and norm v separately. So how we find inner product of uv using this? So inner product of uv is equal to inner product of 5 1 comma minus 2 3 can be written as, कैसे फाइंड करते हैं इनर प्रोडक्ट, ये जो फर्स्ट एलिमेंट होता है ना इसका मल्टीप्लिकेशन इससे आएगा. सो 5 इंटू माइनस 2 प्लस 1 इंटू 3 दैट इज इक्वल टू माइनस 10 प्लस 3 इक्वल टू माइनस 7. देन नॉर्म यू इज इक्वल टू अंडर रूट ऑफ इनर प्रोडक्ट ऑफ यू कॉमा यू इज इक्वल टू रूट ऑफ 5 स्क्वायर प्लस 1 स्क्वायर दैट इज इक्वल टू रूट 26. नॉर्म v इज इक्वल टू अंडर रूट ऑफ इनर प्रोडक्ट ऑफ v कॉमा v इज इक्वल टू under root of minus 2 square plus 3 square equal to 4 plus 9 equal to root 13. After getting all values put in cos theta, then we get minus 7 upon root 26 into root 13, and root 26 can be written as 2 into 13. So root 2 into root 13 into root 13. Root 13 into root 13 is 13 root 2. So minus 7 upon 13 root 2. Cos theta is equal to minus 7 upon 13 root 2. So this, then we can write theta is equal to cos inverse of this. So this is the angle between two vectors. Then next problem is, show that norm of u plus v bracket square or norm of u plus v square is equal to norm u square plus 2 times inner product of uv plus norm v square. Now how we prove this? So norm of u plus v square is equal to inner product of u plus v comma u plus v. Now how we write this, how we split this inner product of u plus v comma u plus v? Listen carefully here. First ये जो u है, जैसे हम दो ब्रैकेट का मल्टीप्लिकेशन करते हैं सेम हियर, सो इक्वल टू दिस स्टेप इनर प्रोडक्ट ऑफ u कॉमा u आएगा. ओके, मीन्स u इसके साथ प्लस इनर प्रोडक्ट ऑफ u कॉमा v मिलेगा, मीन्स ये. नाउ सेकंड टर्म क्या है, v can be written as plus inner product of v comma u, means this, and plus inner product of v comma v, that is this. Okay, but we know that inner product of uv equal to inner product of vu, and therefore this is inner product of uv equal to inner product of vu. If we take here, then we can write 2 times inner product of uv, and this inner product of u comma u, inner product of v comma v as it is. And what is this inner product of u comma u? That is norm u square, and inner product of v comma v is norm v square, and this 2 times inner product of uv as it is. So this shows that norm of u plus v square is equal to norm u square plus 2 times inner product of uv plus norm v square. Okay, so these are the some problems on inner product, norm, angle between two vectors, distance between two vectors. Okay, so same problems are given in practice session. Okay, you try these problems. So first problem is here, examine which of the following functions define an inner product on R2 for u equal to, means same problem लिया हमने, for u equal to x1 x2 v equal to y1 y2. अब देखो यहाँ पर inner product define किया है, inner product of u v equal to this. So using this you check that three properties, which one is inner product or not, then second, third, fourth. Okay, check separately. Then find distance between u and v on R4. This is also simple. Find distance between u and v on R3. This is also simple. Angle between u and v in R2. This is also simple. And last two problem is on. For solving last two problems, take the help of this problem. Okay, so these are the some concepts on inner product space. In next video we will start orthogonal vector, orthonormal vector, orthonormal basis, orthogonal basis, and then Gram-Schmidt process. Thank you.